Good morning, class. Welcome to this extra special edition of Eureka Math in the Morning with Mr. Leggett. You're going to need your problem set, page 73. Today's date is October 6, 2020. So, page 73, 2020. Pause the recording so you can get your problem set up. All right, we're going to start off with, if you paused and now you're back, I'll say welcome back. Let's take a look at a few things here. Today, our objective is we're going to be decomposing a liter to reason about the size of 1 liter, 100 milliliters, 10 milliliters, and 1 milliliter. So let's get started. Okay, let me put my glasses on so we can get started. And let's take a look at this measuring cup. And Mr. Leggett has filled it up to approximately 1 liter. This is 1 liter of water. The way we abbreviate liter is a capital L. So we would say this is 1 liter. Now, let's take a look at this glass of water. What holds more, this glass of water or a swimming pool? And if you said this glass of water, you probably have never seen a swimming pool. Of course, a swimming pool holds more water than this glass of water. Now, think about a bathtub. Does a bathtub hold more water than this glass of water? If you said no, you probably have never seen a bathtub. Of course, a bathtub holds more water than this single glass of water. Agua, H2O. It's a spot. Now, let's discuss this. The amount of water inside, the amount of liquid a container holds is called its capacity. This glass has the smallest capacity because it holds the least amount of water. Is this container filled to capacity? No, we could fill it more. Let's do that. Now, we're talking. This thing is practically filled to capacity. It looks like I can fit a little more water in there, but its capacity would be how much liquid it could hold. That's its capacity. Say capacity, capacity, capacity. That's how much liquid an object can hold is its capacity. Capacity. All right, let's discuss liters a little more. Now, we're going to compare the capacities of different containers by pouring 1 liter into them to see how it fits. And let's take a look at container number 1. So on your problem set, it reads, predict whether each container holds less than, more than, or about the same as 1 liter. Okay, here's container 1. Here is 1 liter of water. What do you think? What is your prediction? Go ahead and pause the recording and circle your prediction. Well, here we go. Let's see if you predict it accurately. Oh no. It has less capacity than 1 liter, it would appear. So if you wrote less than, you got it absolutely correct. You predicted it correctly because it is indeed less than 1 liter. Now, let's take a look at its actual, and I wish I had my graduated cylinders here, but I don't. So I'm using measuring cups. Not very scientific of me. And we're going to measure how much this capacity actually is. Capacity. Ooh, Ooh, my goodness. So you can't see that, but I can. And it's 450 milliliters. And the way we abbreviate milliliters, get a load of this, is a small m, large L. So in the actual section, we're going to put 450 milliliters. Now time to pour this back into the liter jar that I've made. And let's compare another container, shall we? What about this fellow here? Will it hold a liter? Let's find out. Oh, make your prediction. Less than, more than, about the same. Oh, it's holding more water than I thought it would. Oh, and we've reached the container's capacity. Looks like it's less than 1 liter. I hope you got that right in your prediction. Let's see how much capacity this jar has. And this isn't exact because, I don't want to spill water all over the place. And wow, 475 milliliters, ml. That's where you put in the actual. And I found that surprising because that means there's 25 more milliliters in this, in number 3, right? And number 1, or number 2 than number 1. Interesting. I think so. Maybe you don't think so, but I think it's interesting. Now let's figure this out. What do you think about this container? Container number 3. Will it be less than, more than, or about the same? Let's take a look. Please make your prediction. Let's find out. Maybe it's going to be about the same. I don't know. We'll find out what its capacity is. Capacity. You have to be very careful when working with water. Look at that. Look at that. It's about the same. It's about 1 liter of water. So this one, number 3, was equal to 1 liter. So if you put about the same, you got that absolutely correct. Now you want to abbreviate that as the number 1 and a capital L. So you would say about the same, right? Is that what it says? About the same as, and a 1 liter, and the actual would be 1 liter. So that's number 3. Let's go to number 4. And you're going to be making this prediction also. And what we have here, let's find it. Whoa. Look at this. Do you think it's going to be more? Its capacity will be more than 1 liter? Less than 1 liter? About the same as 1 liter? Let's find out. Oh, look, I'm all out. And there's plenty more to go. Let's find out how many liters this is. Please bear with me as we do this. This is going to be really exciting. Remember, liters, capital L. So now we have 2 liters. And milliliters, ml. And it could be a small l or a capital L in that instance. Well, look, its capacity is slowly building up. I wish you could see it over here. I wish I had a camera person so they could, what's the word I'm looking for? They can come on over here and see me filling up this thing of water, because it really is very fantastic and quite incredible. It's probably like nothing you've ever seen before. We got 5, and it looks like we are going to top out at approximately 6 liters. Yeah, that's its capacity. I don't want to go any further because I'm going to explain, but let's take a quick look over here. Look. This, ladies and gentlemen, boys and girls, damas y caballeros, is 6 liters of water. So in the actual, you could put a 6 in capital L to show 6 liters of water. All right, let's see what's next on our problemo set. See if it's time to pause. Let's stop right there. And we'll go to the next video now that we've explored the fabulous world of liters and milliliters.